Hi, good morning to you all. My name is Detlef and I'm a teacher, but I'm now a product specialist for BMS education. And I have been teaching for many years, and at the moment I'm involved with the outreach program for BMS education. This is a tool which includes blended learning, and this is to help the teachers in their work. Now, science is a very interesting subject and it's great fun, but besides that, science is important in the future career. Most professions like engineers and doctors will need science. So let us encourage the children to follow this path. Today we are going to focus on two experiments. One of them is for grade 11, and this experiment deals with the rate of reaction in chemical reactions, and the other one is for grade 12, which deals with the internal resistance of a battery. Some concepts in science are difficult to understand, and we find that it is far easier to remember if the learners can see and do. A hands-on experiment is a far better way of teaching than just a visual one. What we at BMS Education have done is we have set up kits for these two experiments, and they contain everything that you will need in the classroom. But what I always tell the students is that there isn't much to learn in science, but there is a lot to understand. We do this through a concrete representation of an abstract. Putting all these components together can be quite complicated, and we are here to assist you in getting them right. Now these experiments coincide with the CAPS practicals that have been prescribed in the syllabus. Now let us have a look to see what is inside the kit. Now this is the circuit board that we're looking at, and all the components have been included on this board. When we do the experiment, we are going to remove them and just apply those components that are needed. But these here are the switches that we have. These here are the bulb holders, and in order to put a bulb in, we take the bulb out and we screw it into there, and there is our bulb. And these are three resistors. There is a 10 ohm, a 15 ohm, and a 22 ohm resistor. This here is a variable resistor. By rotating this, you can control the current flowing through the circuit. And then we have these are our connectors with the crocodile clips to clip onto these pins wherever we need to complete our circuit. We have the red ones, which are attached to the positive side, and the black ones to the negative side. And these are three coils here. We have a nichrome wire, we have a copper wire, and a constantan wire. Now also in the kit here, we have a pin, and we have our battery holder here. Our cells go there, and we can have up to 4 cells, but sometimes we only want to use one cell. Then we put the one cell in, and we connect to those 2 points. If we need 2 cells, we are going to put it there, and then again we have these 2 cells. And then for 3 cells, we have those 2 points, the 3 cells are there, and for 4 cells we don't use the pin, and we just have the full length there. But I hope you have enjoyed looking at the kit. We are now going to proceed and have a look at the apparatus and do a hands-on experiment. Right, this is our Winchester circuit board, and we are now going to do the experiment, and we use a voltmeter here which will go across our battery, and an ammeter which will be in series with the rest of the circuit. To complete our battery, we have our 4 cells, and they fit into this compartment, and we are just going to tighten this up to make a good contact. There's our contact. We are going to use a 10 ohm resistor, we're going to put there. That is our external resistance. This is our switch, which we are going to put here. And we are now going to connect up our wires to the circuit to complete the circuit. So I'm going to have that there going to there, and then the positive going to the positive there. Sorry, let's just and then this part of the circuit we have to put our resistor in series. And we have to connect that to that, and then this one goes from there to there. My reading here is 6,2 volts. So I'm going to write down my EMF, which equals 6 volts. And when I close the switch, my voltage has dropped and I've got a 0,5 amps. And my ammeter are 0,5. And the external resistance that I've got here is 10 ohms. And my capital R is the external resistance, and that's 10 ohms. We can calculate the internal resistance by using the formula which you will find on your worksheet. And we have EMF is equal to the external resistance times the amps, which was 0,5, plus the internal resistance times 0,5. Now, from your mathematical knowledge, you can take out the common 0,5, and that's 10 plus small r. And then from that, we remember that the EMF is 6 volts, so we got 6, and we bring that to this side, it's 0,5 there, which is equal to 10 plus small r. Right, this here, this comes to 12, and that's equal to 10 plus r. Now that 10 can come to the side, so we subtract it. So we have 12 minus 10 equals r. In other words, then r is equal to 2 ohms. And the internal resistance of the battery is 2 ohms. Please feel free to contact BMS Education for any other resources that you may require.